Okay, so what I want to move on to is looking at again the reaction of the alkali metals with oxygen, like how do they react with oxygen. So again, we'll just stick with lithium. So lithium is one of the alkali metals. So if we have a look here, so this again, it just shows a basic reaction in relation to lithium. So we have lithium plus oxygen will give us lithium oxide. So we basically get lithium connecting to what's called an oxide, and we'll talk about that. Now, in order for this reaction to happen, you have to add heat. Okay, so you have to actually add heat to get this reaction going. So you would call you'd have to heat. You have to actually heat it up. Okay, so just bear with. So we would have heat. Now, this can be known as a catalyst. It's something that starts the reaction off. So you would take some lithium, you would hold it in oxygen, you would heat the lithium up, and then that will get the reaction going. And this is what's known as a catalyst, or it's something that starts the reaction or gets it going. And you get what's called lithium oxide formed. Now, again, if we want to look at it in a little bit more detail, we have this, okay? So you have 4 lithium atoms plus a molecule of oxygen will give us 2 lithium oxide compounds. And again, we will look at that in a little bit of detail in relation to like how the electrons move. Because again, remember, all chemical reactions are based on the movement of these subatomic particles that we call electrons. So if we have a look here at this video, it just gives a demonstration of this chemical reaction. So again, this reaction is a way that we can take something that's happening, let's say in the real world, and we can put it down on paper so that we can think about it and understand how it, like what's actually going on beneath this reaction that's happening that we can see with our senses. And then also as well, when we start to look at, for example, we'll start to look at this when we start to use models like these here, for example, Bohr models, to understand how the individual atoms react with each other. Again, that's what science is about. It's about um, building up models to explain phenomena that we can actually observe in the real world, such as if we take lithium, for example, and we burn it in air, we get a particular kind of reaction that happens. How do we explain that on paper? So let's have a look at the reaction and just to see how this happens.
If we heat a sample of lithium metal, we see that the metal melts quickly. Group 1 metals have a relatively low melting point. As we continue to heat the metal, the lithium reacts rapidly with the oxygen in the air. Lithium oxide and lithium nitride are formed. The smoke that we see is actually the compound. If we let a little bit of the smoke be pulled into the flame, we get the characteristic flame test for lithium compounds, which is a characteristic crimson color.
Okay, so that's basically that's the chemical reaction, and this is what it looks like when we write the chemical reaction down on paper. So we get lithium and oxygen, and we burn it. We add heat, and then we get this other substance that's formed, which is known as lithium oxide. Now remember, these two chemicals that are on the left hand side of this arrow are known as the reactants because they react together, and the chemicals that are on the right hand side of this arrow are what are known as the products, because it's what's actually produced. So you have the reactants and you have the products. So, and the arrow indicates that the reaction goes in this direction. And then, like I said, we have to add heat. So heat is what's known as the catalyst. It's what kickstarts or gets the reaction going. Again, we can represent this like this. So instead of just using words, we use the chemical symbols as they appear on the periodic table. So you see here we have Li, which represents lithium, we have O, which represents oxygen. And then we can see here that these atoms join together and they form this compound which is known as lithium oxide. But again, we're just using the symbols that are on the periodic table. Now you'll notice that you have this number that's in front of the symbol. So in this case, it's 4. That means there's 4 atoms of lithium. Now see the way we have this small number, which is known as 2 beside the oxygen. That means that there's 2 atoms of oxygen joined together. This means that there's 4 individual atoms of lithium. Again, see the way we have the 2 in front of this here? That means that there are 2 compounds of lithium oxide. This small 2 that's beside, that's underneath the lithium symbol here, that means that there's 2 atoms of lithium. So it's just important to know what the numbers represent. So this is what we start off with, and then this is what we end up with. So let's have a look at what happens in relation to this chemical reaction, in relation to the movement of the electrons. Okay, so what we have here then, and let's just zoom out a little bit. So what we have here, so on this side here, we have the reactants. Okay, so we have 4 lithium atoms and an oxygen molecule. And what happens is they react like so. And we have heat. Okay, so what we have here, so this 4 lithium atoms, this is how we can represent it like this. So 4 lithium, we 1, 2, 3, 4, the 4 lithiums. Here we have 1 oxygen molecule. So see the way we've 2 oxygen atoms that are joined together. That's what this small superscript means. So what actually happens? So again, remember, lithium wants to lose each of these lithium atoms. They want to lose this outside electron. So they want to get rid of it and they want to lose it. So if we think about it from that point of view, so we have this. So basically, imagine this. These negatively charged electrons come off the lithium. Okay, so each of these lithium atoms are going to lose their outside electron. So imagine they come off like so. And what's going to happen is they're going to introduce themselves here into this molecule of oxygen. So imagine they're just going to come in and 2 of them are going to connect onto each oxygen atom. Now, as a result of that, what's going to happen is this oxygen, the 2 atoms are going to split apart. And what will happen is the lithium atoms will become charged positive ions, and the oxygen atoms will split apart and they'll become charged negative ions. So let's say, so here for example, so each one of these, atoms, each of these atoms of lithium will be positively charged. The reason they're positively charged is because they've lost one of their electrons and now they have more positive charge in the nucleus, and as a result of that they will be positively charged. So imagine each of these lithium ions are positively charged, and they will have a +1 positive charge because you will have 3 protons in the middle, which are 3 negative charges, and then you'll have 2 electrons on the outside, which are 2 negative charges, and 3 minus 2 leaves you with 1 positive charge. So each of these is going to have 1 positive charge. Now, if we have a look at, so the electrons that the lithium atoms have lost are picked up by the oxygen. So you have 2 oxygen atoms that are joined together like this before they receive the electrons from the lithium. Now, where atoms share electrons like this, these are known as covalent bonds. Now, as a result, what happens is when this molecule of oxygen picks up the electrons from all of the lithiums, what happens is this disrupts this bond, and the 2 atoms of oxygen, they come apart. So the 2 oxygen atoms come apart like so. And what happens is you'll see here that each atom of oxygen picks up 2 electrons, 1 from each of the lithium atoms. So you can see if we focus just on this one here, we see that we have the oxygen atom has 8 protons in the middle, or 8 positive charges, It normally has 8 electrons, so 2 in the middle, in the inner shell, and then 6 in the outer shell. But because it's after picking up 2 more electrons from each of the lithiums, what happens is it becomes negatively charged. So it has a plus, it has a plus 2, sorry, it has a negative 2 charge. So it's going to be negatively charged. It's going to have, so basically if you think about it, it has eight, eight protons, but then it has, if we count them here, it has one, two, so it's going to have 8 electrons, and then it's going to gain 2 more from the lithium, so it's going to have 10 negative charges. So that's going to be minus 10. So if we think about it, so plus 8 minus 10, that's going to be minus 2. So it's going to have 2 more extra negative charges, so plus 2. Now, as a result of that, it wants to be stable. So what will happen is, so this negative, or this positively charged lithium ion is going to want to come into contact with this negatively charged oxygen ion. And as a result of that, a bond is going to be formed. So what will happen is each of these lithium ions will bond with the oxygen ion, and you get what's known as an ionic bond that's formed. So this is an ionic bond. And as a result of that, you will get lithium oxide. So this is what's known as lithium oxide. So it's basically 2 lithium atoms bonded onto an oxygen atom. And again, the same thing will happen down here. So you're going to get the 2 lithium ions being formed. You will get the oxygen ion formed as well. And as a result of that, these 2 lithium ions will bond with this one oxygen atom, and then you'll get this compound of what's known as lithium oxide. So again, this is just, it's how the alkali metals, how they react with oxygen. So again, you start off with 4 lithiums. So this is 1, 2, 3, 4. Lithium has 1 electron in its outer shell. So in order for it to be stable, it wants to get rid of the outer electron. And when it does that, it becomes a positively charged ion. The oxygen molecule picks up the electrons from the lithium, and as a result of that, it gains more electrons than it has protons, so it gains a negative charge. So it becomes a negatively charged ion. Now, it develops a minus 2 negative charge, so that means it has 2 more electrons than it has protons. So as a result of that, each of these lithium ions, each one will have a plus 1 positive charge. So that will enable 2 of these lithium ions to bond with 1 oxygen ion. And then as a result of that, you get this formation of, so you get 2 lithium ions connected to 1 oxygen ion. And then you get this compound of lithium oxide formed. So again, it's one of the chemical reactions of the alkali groups, and we're using lithium as an example. And again, as I was saying, this same reaction can happen with other group 1 elements. So if we have a look here, so as easily, instead of starting off with lithium, you could start off with sodium or potassium. They're going to react the same way. Sodium and potassium will be more reactive. The reaction will happen quicker or faster than the reaction with lithium, for example, because the electron that's on the outside is further away from the nucleus. So again, this is the basis of a chemical reaction. So what you have is, you have the movement of electrons. And again, what's very important is the types of bonds that you can have. So when ions are formed, and those ions connect together, like with this case here, like with the lithium oxide, that's what's known as an ionic bond, where you get this positively charged atomic species attaching to a negatively charged atomic species. In the case where atoms share electrons with each other, so again, with oxygen, it's sharing electrons here. This is what's known as a covalent bond. If atoms share one pair of electrons, that's known as a single covalent bond. Now with oxygen here, it's sharing two pairs of electrons, so this is known as a double covalent bond. And even with some atoms, you can have a triple covalent bond where they share three pairs of electrons. Why is oxygen sharing those electrons with each other? If you look at oxygen on the periodic table, it'll have 8 electrons in within its electronic configuration. It'll have 2 on the inside and it'll have 6 on the outside. Now, in order for the outside shell to be full, it needs to have 8 electrons. So as a result of that, it has to either take 2 electrons from another atom or it has to share electrons with another atom. And in this case, what it's doing is it's sharing electrons with another oxygen atom. And as a result of that, both atoms get to have a full outer shell because they're sharing electrons with each other. But what that does is it connects the two atoms to each other in this bond, which is known as a covalent bond. Okay, so that's the reaction of the group 1 elements, which are known as the alkali metals, with oxygen. Okay, so that's those, and thank you for listening.